Hello, welcome to another episode of Let's Make It. This is episode 8 of Let's Make It. It's been a fun 8 weeks, and tonight's not going to be any different. We're going to have some fun tonight as well. So, what we're going to talk about tonight is how you could build a traffic light using an Arduino. And actually, if you think about this, the Arduino could really control a traffic light. Obviously, it couldn't turn off and on the lights themselves. However, it can control relays and SCRs that would turn on the lights in a traffic signal. And if you think of how big the Arduino board is, it's tiny, so it wouldn't take much more to be able to control it. And we're even going to go to the point where we're going to determine if there's say that you had a sensor at a light and a car is sitting there, many lights will change faster if a car is waiting. We're going to even demonstrate that tonight using 2 separate traffic lights and 2 different traffic sensors. So we'll be able to determine should we go and change the light faster because somebody is waiting, or should we just leave it where it's at for a little bit longer. So we're going to start out very simple at first, just talking about, and this is kind of like a review in the beginning of how you can create a loop and it would cycle traffic lights. So let me go to the Arduino and show you what I have set up on the Arduino. So here's the Arduino, and it looks like a major cabling mess. And there is going to be a schematic on the show notes. However, it's not so bad if you look at it. You can barely see them, but I have 6 LED lights here, and the reason you can barely see them is they're actually clear, but when they turn on, they're different colors. And you see a red wire, a yellow wire, and green wire. Those are our positive to the LED lights. And then on this side, I'm going to call traffic light 0 and traffic light 1. And the reason I'm calling it 0 and 1 is because in my code, that's how I did it. And you remember when you're writing stuff in the Arduino, everything starts at 0, not at 1. So on the left side is 1, and on the right side left side is 0, the right side is 1. So all the other stuff you see here, you see these black wires, that's our positive, or I'm sorry, the black wires are ground, and the blue wires are our positive, because I want to use obviously red for power because I want to use it for the LED light. And then down here at the bottom, you see 2 switches, and these are going to simulate our sensors that a car is waiting. So here's the sensor for light 0. Here's the sensor for light number 1. So it's not really overly complicated after you look at it and kind of tear it apart. So there's a lot of little wires running around here, but it really is pretty basic. You can barely see in the camera, but I have the resistors for each LED here as well. And I'm just running them over to the ground pin to run right here, which is the black wire that runs from here, then over to the Arduino. So what I'm going to do now is it's already running, so you can't see it's really doing anything. And I'm going to show you the very first basic program. And this program basically looks for a car to be sitting, and it's going to use traffic light 1, the one on the right. And when there's a car sitting here, all it's going to do is cycle. So I'm going to push the button down, and you're going to see it go through its cycle. That's all it's going to do, because I want to go walk through the code a little bit, and then I'm going to show you a new type of structure in the code. So all you're seeing it doing is red, yellow, green, yellow, red. And that's all it's going to do as long as this button is pressed. When I let off on the button, it's just going to stop. It won't go any farther. When I press the button again, it's going to continue. So the code to do this is actually fairly simple, and the initial code I'm going to show you is done using structures that we have talked about in the past, and that is if statements. But what I want to do is I want to show you how you can rewrite that using a switch statement or a case statement. Many people call it a case statement. And make it a little bit cleaner and just a better structure for this type of thing, because what you're looking at here is what's called a state table. So basically you're doing something, determining the state and then performing action. And one of the ways you can do that is set a state and just do a bunch of if, then, else statements, which is how I'm going to show you the code in a second. But there's a cleaner way of doing state tables, and that's by using the switch or the case statements. So let's switch over to the code. And I'm at the very top here, and I'm going to scroll down. This is my comments. And the first thing we're going to do in the code is we're going to define our red pin, our yellow pin, and our green pin. So I'm using pins 6, 5, and 4, respectively, for red, yellow, and green. And then my button is attached to pin number 10. And I want to start at state 0. So I'm going to go ahead and set the variable and set the state equal to 0. Then we're going to come down to the setup, and then we have our very familiar setup options. We're going to define our red, yellow, and green pins to be output pins, and our button pin to be an input pin. Then we come down to the loop, And basically what you see here is the loop says if the button is pushed. So that's when you see me push the button. I want you to do anything in these brackets. If the state is equal to 0, I want you to turn on the red light. So this is set lights is red, yellow, and green. So red is going to be high, and the other two are going to be low. And then I want to change my state to be equal to 1 because I'm done with state 0. So I come past all these if-else's. You see different state. No, I'm not going to match that. And then come down and you do delay for 1 second. We're going to come back up to the top of the loop, and we're going to say, is that button still pressed? And if it is, this time state's equal to 1. So we're going to come down. It's not equal to 0, so it comes down here and says else. If. And then if state equals to 1. Well, it is equal to 1 now. So we're going to say, turn off the red light, turn on the yellow light, and leave the green light off. And then we're going to change our state to 2. And come down here, and since we did this if, the else doesn't happen, so we're going to go on down past that. And we come down and we delay 1,000 milliseconds or 1 second. Come back up to the top. Going to check our button one more time, and it says the button's still down, but now we're state 2, so we skip past this one, else. And we're not equal to 1, so it's else. We come down here. Well, we are equal to 2, so what are we going to do for 2? We're going to turn off the yellow light we turned on last time and turn on the green light. And we're going to set our state to state 3. So then we come down past the else because we just did what we're supposed to do and do a delay of another second. We're going to scroll back to the top up here. Check that button one more time, and if that button is still down, we're going to come down. We're not state 0, and we're not state 1, and we're not state 2, but we are state 3. So I'm going to turn off the green light I turned on last time and turn back on the yellow light. Then I'm going to set state back equal to 0. So I'm going to come back up. We're going to wait a second again. So right here, we're just waiting a second. And we're going to come back to the top. And we're going to say, is that button pressed? And if it is, now we're state 0. So I'm going to turn back off the yellow light I just turned on, turn back on the red, and we start this whole process over again, going through all the different states. Now, probably one thing I neglected to talk about, which I'm going to go do that right now, is the set lights. So this is not a Arduino function. This is something that I created. So if we scroll down here to the bottom, you see function set lights. And if you look at this, I'm bringing in as an integer the red pin, the yellow pin, and the green pin. I'm sorry, the red, yellow, and green as either on or off or high or low. So I come down to digital write. I've set my red pin up in the header area. I'm going to turn it to whatever state I passed in. I'm going to set the yellow pin to whatever state I passed into yellow, and the green pin to whatever state I passed into green. So when we're doing these functions at the top, you can see I'm passing in low, low, and high. This is the state of the pin. When the pin goes high, the light comes on. When the pin is low, the light is off, or the LED is off. So this is what we call a state table, because basically you're referring to state and you're taking action based on what state you're currently in. Now, what I want to do is I want to get out of this program, and I rewrote this loop right here a little differently to something that I consider to be a little cleaner and a little easier to read in the way it's typically recommended you do a state table. So let's go close out of this, and we're going to go to this traffic signal in its case. And if I scroll down, we're going to see everything is the same through the whole program with one exception. So even the setups is the same. We're going to scroll down through here. Nothing's really changed till we get to here. Well, it's not my case one. How embarrassing is that? All right, so I came over to this program that I thought I was ready to show you, and for some reason I don't have it, but this is a good time to show you how to do this live. So here we're going to come down. This is a different project. It's called Signal Case, and I thought I had saved it so that it was done via case statement, but apparently I did not save that. So I'm going to come down here, and so here's what we're going to do. We're going to, instead of saying if state equals, we're going to do this. We're going to put in something called switch, and then it wants to know what variable the switch is. So this is going to be state, and we're going to put it in curly brackets just like this. And we're going to take our very first case statement, and it's going to be the word case. In this case, I want to do something for state 0. So I do case 0 colon, and I'm going to tab over, and I'm going to take this exact same line right here. Oops, a little sensitive on the mouse. And I'm going to copy this, and I'm going to paste it just like this. Oops, I forgot the S. So there's set lights, and then I want to actually do break. So what I'm trying to say is, after I do this, I don't want to do anything else in this case statement. I want to go basically drop out of it. So I'm going to do that, and then I'm going to come down, and I'm going to do case 1. And in this case, I'm going to come down and take this set lights that's right here. My mouse is very sensitive. And I'm going to go up to state, or to case 1. And paste that in just like this. And again, I want to do break. And now I'm going to come down, I'm going to do case 2. And I'm going to use my touchy mouse again and come down, and I'm going to copy, or try to copy if I can stop it. Crazy mouse, crazy mouse. Copy what goes for state 2 right here. And I'm going to break. And then I'm going to do the very last one. And I'm going to do it as case 3. I could do it as case else. Basically, it's the catch-all that way, if nothing else matches. In fact, you could probably do a case else and set your state to 0. That way you're sure where you're starting if ever that becomes an issue. And I'm actually going to take, and I'm just going to type it in to be faster probably than me using my mouse, set lights. And in this one, the yellow light is on, and I'm going to break. And here's the end of the case statement. Now, one of the things you're going to notice is I never added up the state, and I'm going to do it differently. Down here, we're setting it to a number. I'm not going to do it that way. First of all, let me get rid of all of this stuff that I don't really need. If I can get my mouse to cooperate. All right, so I'm going to get rid of this. So basically, the state goes up, up, and up until it gets to the end, and then it gets reset back to 0. So the quick way to add to that is you just do plus plus state, which adds 1 to it. And then I'm going to put the statement, if state is greater than 3, I just want to set state back equal to 0. So let's go back through and review what I just did. I just converted those if-else statements to case statements, which is something we haven't talked about before. So basically, I'm doing the same thing. If the button is pressed, I want to come down to this case statement using state as the case. So in the first time through, it's equal to 0. It's going to set lights to high, low, and low. And then it's going to come down, break out of this. Break basically means you come down to the end of this, and it's going to add 1 to state. So state's going to be equal to 1 now. So it's not greater than 3. So I'm not going to do this equal 0. I'm going to wait 1 second, come back up to the top, check that button again. And now my state's equal to 1, so I'll come down to case 1, and it's set lights, and so I'm going to turn the yellow light on and turn off the red light. I'm going to drop out of this, increase the state by 1. I'm now at 2, so I'm still not greater than 3. So I'm going to not do this. I'm going to delay my 1 second, come back up and check that popular button again, and now my state's equal to 3. Equal to 2. Right? Yes, equal to 2. So I lost track of where I was. Set lights equal to low, low, and high, which basically means the green light comes on. Drop out of the bottom. I'm going to add 1 to it. Now I'm equal to 3, but I'm not greater than 3, so I still don't do this. I'll wait 1 second, go back up, check the button 1 more time. Now I am equal to 3 when I come down, so my state case 3, I set my yellow light on and green light off, and I drop out of the bottom, which I'm at the bottom already, so there's nowhere really to go. I add 1 to state, now I'm equal to 4. So since state is greater than 3, I set it back to 0, which means it comes back up to the top and we start all over again. So this is how you do it with a case statement. This is much cleaner than doing the if then else. It's much easier to follow. And you could actually go through and you can add comments to the end of the line if you want. Just like that, so you can tell what each case area does. So it's much easier to read than an if then else, if then else, if then else down the line. So that's case statement. So I'm going to save this because I didn't save it before for some reason. But the other thing I'm going to do is I'm going to, first of all, check it. I got no errors, so I'm going to upload it. And it's been uploaded. So let me go back over to the Arduino now. And you see the lights are off because it just started. I'm going to go ahead and press down the button. And there we go. Down the line, back up the line, and we do it all over again. So you just watched me, even though it was a failure on my part for not saving earlier, you just watched me recreate the program by taking out the if statements and using a case statement. So I want to take this project to the next level now. And how I'm going to do that is I'm going to add 2 lights. You saw I have 2 lights on here. I'm only using the 1 light. I'm now going to load a program that uses both lights and has some logic about cars waiting in line. And then we're going to walk through the code so you can see how it works. And I'm still using the case statement in there, definitely using the case statement in that program, because that's how I wrote it from scratch with. But using that, we can determine ways you can look at other conditions. Like I could add a walk light, things like that I have not put in there. I just basically did basic red light type scenarios. But it's a good way to learn structures and as far as states, state trees, things like that. You can figure out all that stuff using the code. Now the other thing that I've done inside of the code is I've put in code that writes back to the serial port, because by looking at it, unless you're going to sit there with the timer, you're not going to be able to tell that I'm going to wait 15 seconds here unless there's a car waiting, and then I'm going to go earlier than that. So in the serial output, if you watch the serial output, it tells you what it's doing. And basically, let me tell you a little bit about how it's set up to work. And let me bring it up on the screen here and tell you to make sure. No, I don't want to do that. Let me open it up. Multi-light. Okay, so the way I have the code set up is and we can read the comments exactly as I have it. So light 1 will be green and it'll wait for 10 seconds if a car is at the light, at the other lights. And it'll wait for 20 seconds if there is no car at the other light. And then it comes down, and the other light is a little bit longer than that. That's how I can tell you the difference. Light number 2, or what I'm calling light 1, I should probably say, is green for 15 seconds if there's a car at the other light. And it's 25 seconds if there is not a car at that light. Now, anywhere between the 15 and 25, if a car shows up, it should immediately change to yellow. And it'll work the same way with the one that is 10 and 20 as well. So by reading the output on the serial port, when you press the button, you can wait till you get to like 12 or 13 seconds and then hit the button, you'll see it immediately switch over. So I can demonstrate that on the Arduino itself, but it doesn't mean as much if you can't really see what's coming out of the serial port. So let me go load this program in really quick. And I'm going to go back to the Arduino. All right, so now what you're seeing in the Arduino is 2 lights. Well, light on the right on the left is, in my comments, it's light 1, the other one's light 2, but it's actually in code, it's light 0 and light 1. Because remember, the Arduino always starts at 0, not 1. And you see that the green light is on at the leftmost light, light 1, and now it's turning yellow. So it must have waited 20 seconds. And then it'll wait for yellow for 10 seconds. And then it'll go red, and it'll wait a couple seconds till the other side goes green to leave cars clear out of the intersection. Because you never want cars to, everybody runs the red light once in a while, so you just don't want to go immediately. And then this side's going to be a little bit longer. It's actually going to wait without a car for 25 seconds. So we're going to sit here and we're going to watch this light for 25 seconds, and then it'll go to yellow, 10 seconds, and then red, a couple seconds, and the other side will take over. And it makes for a long 20 seconds when you're sitting there, because now we're in yellow. And then it'll go red. Yep, there goes red. And then a couple seconds, the other side will go green. So we just went through the entire cycle. So now what I'm going to do is I'm going to push the button over here that tells me there's a car waiting in this other light. And we'll see that the green light goes much quicker on this side. See, now it's already going to yellow. And the only thing it's speeding up is the green light. It's not speeding up the yellow or the red light at all. And now we're red, and then a couple seconds to clear out the intersection, the other side will go green. And this is going to be another long 25-second wait, unless I say there's a car waiting here. So I'm going to go say there's a car waiting here. So this light would now be 15 seconds because there was a car waiting. So you see it's faster. And we go through this process to red light, and we're going to go back to green. And the other side says there's still a car waiting there, so this was still going to be fast. So you can determine what car is waiting and where. So what I want to do is I want to go in and walk through the program and show you how I did this. And I may even come in here and show you the output from the serial port. Actually, I'm going to go turn that on while we do this because I can get some logs in here while we're doing this. All right. Okay. Let me take you back over to the code. And going to scroll up. Having some funny mouse problems tonight. Okay, so this uses some of the same stuff that I had in the other first project. There are some additional things though. So here you see, rather than defining just red pin as pin number 6, I'm now defining it as an array with pin 9 and 6 because now I have 2 lights. So what this is going to do is I look at red pin 0, light 0, it's going to be pin 9. If I look at red pin 1, which is the second light, it's pin 6. So I've done this now for red pin, yellow pin, and green pin. I also have to do that for the button pin. So button pin 0, which is the light on the left, is pin number 11, and button pin 1 is pin number 10. I'm still using a state table just like I did in the other program, and I start out at state 0. So we're going to come on down, and you notice the setup is a little bit different. Basically, there's more things in here because now I've done setup pins for light 0 using red pin 0, yellow pin 0, green pin 0, and I did the button pin 0 for input. And then I defined light 1, red pin 1, yellow pin 1, green pin 1, etc. down the line. And the other thing I've added, and this is more, because if you watch the serial port, you download this code from the website, you may get a better idea of what it's actually doing just by watching the serial port and what it's thinking as it goes down through here. So I've activated the serial port at 9600. Now we come down into the loop, and the first thing you see is an integer declaration of a wait counter. WCNT is what I called it, for wait count. Then we come down to our very familiar switch statement, which we just talked about in the last program, and state 0. And I come in here and I set lights. I set light 0 to green and light number 1 to red. So why do I set light number 1 to red? Well, the main reason is I don't know what state it's going to be in when the program starts running. This is my way of saying for sure that one light is green and one light is red. I would hate to turn this first light green and the green light already be on light number 1. So it's just a safety thing to make sure that you actually have a red and a green light, not 2 greens right here. And you see I'm printing out on the serial port, light 0 has just turned green. Now here's where the wait count comes in, because this only happens on green lights because of the waiting for other cars. And you see my comment right here. I'm going to loop for every 1 second, and after 10 seconds, I'm going to look at the other light. And if a car is waiting, I want to go ahead and switch the light to yellow and start changing the lights. But if no car is there, I want to wait for 20 seconds. So here's what I'm doing. I set my wait count equal to 0, and then I do this whole loop while my wait count is less than 20. So when I get to 20, I'm going to go ahead and go. And my wait count is not greater than 10 and a car waiting at the other light. So in the event there's a car waiting at the other light and my wait count is better than 10 seconds, I'm going to go ahead and drop out of this loop and start the process of changing the light. So in the loop, what I'm doing is I am, for debugging purposes mainly, and for you to try to see what it's doing, is I'm printing the loop count. So as you play with the buttons, you can wait till it gets to 12, for example, hit the button, you're going to see that it immediately goes and says there's a car waiting, and it continues on. And then right here, just so you can tell what state the button's in, I'm going to read the button for the other light, and if there's a car there, I'm going to print out on the serial port, a car is waiting at light 1. Then I come back down to the while statement, which we just talked about, and then when that's over, I drop out. So when either it's more than 20 or it's greater than 10 and a car is waiting, it drops out of this, and it comes down to the bottom of the case statement, and I do like we did before. I increase my state and go back to the top. So now I'm coming around, and my case is equal to 1, or loop's equal to 1. So my state's equal to 1. So I'll come down to case 1, and I'm going to turn on the yellow light. And you notice right here, set lights is a little different. I'm telling it which light I want to change. So set light 0 is the leftmost, and set lights 1 is the rightmost. And we're going to walk through the program, and you can see how I did that based on the arrays that I created above. But right here, I'm going to take light 1, and I'm going to take it yellow. And I'm printing out on the serial port. It turned yellow, and I'm waiting for 10,000 milliseconds or 10 seconds. And then I'm dropping out of this case statement. I'm coming down to the bottom. We're going to increase the state by 1. We're not greater than 5 yet, so we're not going to do anything else. And we're going to come back up to the top of the loops. And when we get to the top of the loop, my state is now 2, so I'm going to scroll down to case 2. And now I am turning the light to red for light on the left, and making sure that yellow and green are both off. I'm going to print out on the serial port, light 0 is red, and I'm going to wait 5 seconds. This allows time for traffic in the intersection to clear out. I'm going to break out of this. We're going to go down to the bottom and increase it by 1 again, and we're still less than 5, so we're going to go back to the top. And we're now state 3, so there we're switched state 3. So we're going to come down, past case 0, past case 1, past case 2, and here we are at case 3, and I'm going to turn the second light, green, light 2, or light 1, however we looked at it, and I'm going to go through the same wait loop that I did with the other light. Now here you're going to notice that I'm going to wait for a different amount of time. So actually, I'm supposed to wait for a different amount of time, but I'm not. So let's change this to 10 and 15, or 25 and 15. I love debugging as I demonstrate. So here we're going to do the same thing we did before, except this time I'm going to look for a car waiting at 15 and 25. So this light's going to be a little bit longer than the other one. So here I'm doing my do loop right here, a do while. I'm going to delay 1 second for every time, and then I'm going to increase my count by 1. I'm going to print out to the serial port just like I did with the other one, so you can tell how many seconds it's been waiting. And then I'm going to look at the pin, and I'm going to tell you if I think a car is waiting there or not. So the while statement says while the count is less than 25, and not if, okay, this is a not right here. So it's while the count is less than 25 and not more than 15 seconds and a car waiting. Yeah, I want you to sit in this loop. So anytime it's greater than 15 seconds and you see the car waiting, you're going to drop out of this while loop, or if it waits 25 seconds, it will drop out of this while loop. And then we come down to the break, and we go to the bottom, increase our state 1 more time, and it goes to state number 4 this time. So we come back to the top, come back to our switch, and we're going to go look for case 4. And in case 4, I'm going to set the yellow light, and I'm going to print out to the serial port that light 1 is yellow, and I'm going to wait 10 seconds. And then I'm going to drop to the bottom, and again we increase our state. This time we're equal to 5, but yet we're not greater than 5. So we come back to the top, and we come back to our our switch statement, and we go look for case number 5. And we come down to 5, and then I'm turning the light red, and I'm setting out serial port, telling you that I turned it red, waiting for 5 seconds, and then I'm dropping to the bottom, increasing state 1 more time. This time we're equal to 6, so we are greater than 5. We start back at state 0, and this starts all over again. And it continues like this forever until you unplug the Arduino. So that's basically what is happening. Now, what I want to do is I did bring up the serial monitor before I did this, so it should be some good stuff going by. All right, so now you're going to see the serial stuff that I put up there. So right now we're saying a car is waiting. So light 0 just turned yellow. The light on the left just turned yellow because a car was waiting, and it got to 11 seconds. Now, to make this proper, what I should do is actually push out, let me get this up here. Since I fixed my little bug as I was doing this, let me push this up so you see the counts actually matched in this way. All right, now it's running. Let me go to serial monitor. Okay, so I'm going to turn off any waiting cars at this point. So you see no more cars are waiting. And we're at the leftmost light, or light 0, which waits for 20 seconds and then turns yellow with no cars waiting. So light 0 turns yellow. Light 0 turned red. Now we're in that 5-second wait period, waiting for the cars to clear the intersection. Okay, light 1 turned green, and we're going to see it count up to now 25 because there's no car waiting. And this is going to be a very long 25 seconds. Although we're not too far from being done already. So we're going to keep on going past 20, hopefully. Yep, 20, 21, 22. All right, so here we go, 25, light turned yellow. So that's 25 seconds. And light is yellow for 10 seconds, then it turns red for 5 seconds, and then the other one turns green. And this time I'm going to wait till it gets to like 15 seconds, and a car is going to show up. So we'll wait till we get up here above 10, basically is what I'm trying to do. Okay, so anytime now if I press the button, it's going to have a car show up. So here it goes. Okay, car showed up. It immediately went to the yellow light because it's all car waiting. It's red, and I'm actually going to do the same thing on the other side because I don't want to sit here for 25 seconds again. But this time I'm going to push it a little bit early. So now a car is waiting before it's allowed to go. And you see it's going to keep counting until it gets to 15, because 15 is the magic number for this one. There it goes, light turned yellow. Instead of going to 25, this time it went to 15 or 16, greater than 15. So that's basically what it does. So this program is going to be available, obviously, for download on the show notes, and it's kind of a fun thing to play down. You don't have to have lights even attached to it for this to work. I'm using lights just for fun, and you can see over here, if I go back over to the Arduino, that, well, let me see, I have a car waiting. All right, it's turned yellow and turns red. It's a fun thing to play with. But it does work without having the lights if you just want to do through the serial port as well. You will need 2 switches to simulate a car waiting. That's the only thing you really need. And if you don't do that, all you're going to see is it keep going around in a circle, waiting for 20 seconds and 25 seconds to do that. So right now I have cars waiting at both lights. So it's 15 seconds. It's almost up. There it goes. Now, there it goes. So that's the red light example. And the main thing that I wanted to really, well, it's 2 things I wanted to show you. First of all, how you can do sensor inputs, which basically I'm looking at these as being sensors. I mean, car is there. It could simply be a contact closure. And to control the output lights, you could take any output, do an SCR and a couple other layers of stuff to relays or whatever to control lights. You could truly control a traffic light with the Arduino, which is that little bit of code that I just did if it was a basic traffic light. And you can see how you can add things in there. But the other thing I want to show you is the case statement and state tables. That was the thing I wanted to try to cover this week. It's a programming concept that if you're a programmer, you're probably already familiar with. But if you're just playing with the Arduino and learning it, you may not have ever heard of a state table before. But where this comes in very handy is if you're doing something in communications where you're trying to talk to the other side in a protocol, there's generally a handshake that goes through, and you're in certain states in that. So that's where you use the state table is you set it to the state, I'm trying to connect. And then after you get connected successfully, you change the state to negotiating. And then you change the state to communicating. And you change the state. So you're transmitting a packet or a payload. I'm transmitting the payload right now. I'm waiting for results back. So it's called a state table. It just helps you keep states. The other thing I wanted to cover was the case statement. Seeing lots of examples out there, people are using if-then else's on it. That really isn't the cleanest way to do it. Now, the one thing I was trying to do, and this is maybe me, I haven't quite figured out how to do it. I've created libraries and classes in the Arduino, but writing them in C++, not in the Arduino. I was going to try to demonstrate how to create a class, but it's not obvious how to do it, and I'm not sure you can do it in the Arduino itself. I know how to do it in the libraries, but I'm not sure that it can be done in the Arduino. And if you know that it can, please let me know and let me know how, because I'd love to demonstrate that to other people, because looking for it wasn't obvious to me how to do it. So that's pretty much it for this week on Let's Make It. I do want to remind you that you can get all the show notes by going to techzen.tv and going into Let's Make It, and every episode has detailed show notes in there as well. And if you're watching us on YouTube, please hit the subscribe button at a minimum. But the best way to get us is completely automatically by going to something like iTunes and clicking the subscribe button. Where you get us on your device when it becomes available. There's no thinking; it just comes down and it'll show up on your iPhone or your iPad or whatever podcasting you want program you use. Like if you're on Android, something you like to use, definitely subscribe to it. And you can get to all the subscription links on our website or at most of your favorite podcasting directories these days. And if you're on a BlackBerry, you can get us on your BlackBerry. If you have a Zune still, you can still get us on the Zune. If you have a Zune player on your Xbox, you can get us on the Xbox. We're even on a TiVo now. So if you want to watch us on the big screen, go into the TiVo and just do a season pass for Let's Make It, and you get it every week automatically downloaded right to your TiVo. If you have comments, we love to hear them, and I'd love to hear things you want us to show you. And if you have comments on what we did tonight or better ways to do things, we would love hearing that stuff. And there's a couple ways you can do that. We actually have a phone number you can call and leave us a voice message on. You get that from the show page. You can send us an email. You can find us on Twitter. Our Twitter accounts for Let's Make It is on the show page as well. Everything you need to know is on the show page. The best thing to do is go to techzen.tv and look up the show page, and you can contact us many ways. And if you'd like to send us a video, we love to see your videos, and the best way to do that is to record it, upload it to somewhere like Vimeo or YouTube, something like that, and just send us the link. Because so many times it's just too big to be received via email. So, like I said, that's pretty much it for this week. Go download the code and play with it. And like I said, the only thing it needs 2 buttons really to test this. That's kind of why I did the last program the way I did. And it also helps you, if you do have the lights like this, to kind of watch what it's doing, and it's kind of fun to play with. But you can now add your own traffic light to anything you want. Model railroads, whatever. You can have all kinds of fun with it. So, all right, we'll see you all next week on Let's Make It.